Hey guys, how you doing? It's Coach Scott with another edition of your chemistry class, right? Your chemistry class. So let me narrow down a little bit. What we're going to cover now, this is our second video. Oh, not the way to go here. Oh, I wanted to get me. So this little video, we're going to explore, what are we going to explore? Oh yeah, we're going to explore ions. Ions, yeah. So anyway, looking forward to it, and let's get going. Okay, so ions, that's probably a little big, so let's go down a little bit. Okay, it's so cool that I can move myself around all over the place. But anyway, yeah, having a little fun. So what are ions? We covered this a little bit in Unit 3, all right? But what ions are atoms, really, groups of atoms that have been charged, okay, or they became charged, but either one, gaining an electron or losing an electron. So, two new definitions for you. We have cations. Cations are positive, and they're formed by elements on the left side, pretty much on the periodic table. The common cations you're going to see would be hydrogen, okay, lithium, sodium, potassium, rubidium, cesium, all the group 1 cations. You've got the group 2 cations, magnesium, calcium, strontium, and barium, right, and barium. The anions, new name. Anions are negative, and they're formed by elements on the right-hand side of the periodic table, like right over here, right over on here, right? They're the nonmetals, and those are the ones where we'll usually see that are going to be negative, right? Because why? Because they have they really want to lose electrons. All right, they really want to lose electrons. Noble gases, they don't lose squat. They want to just keep doing what they are doing. They're happy. So how does this happen? So cations, you have sodium, right? Neutral sodium atom has 11 protons, 11 electrons. It's got a very low first ionization energy. Now, if you look at the size, and if you think about Zeph and you think about shielding electrons, all right, Zeph will increase to 11, or it stays the same. It's still got like +1, right? But now you've only got that 1 electron. You still got those 10, so you still got that +1 charge pulling against what? So what's happening? All right, that sodium ion, because of those nuclear effective charges, is going to shrink and be smaller than the sodium ions. And what causes it? Well, two things affects atomic size. Zeph, all right, and the layers of electrons. And of course, if that electron in like level or energy level 3 goes away, that 3s, I believe, 3s electron, it gets pulled away or it gets lost to another entity, all right? Now you only got 10 electrons, and it's going to get much smaller than the sodium atom. Okay. So, metals will usually give up the valence electrons to become more stable. And what happens is this will result in a noble gas configuration, a noble gas outer shell, and S2P6 outer shell. So sodium, if you look at the configuration diagram, it's got a 3s electron. It loses that electron, it becomes happy, it becomes more stable because all of its energy levels, all of its orbitals are filled with electrons. So in a +1 cation, we'll have a configuration similar to neon of 1s2, 2s2, and 2p6. So how many electrons does the sodium ion have? It has 10, just like neon. Now cations, okay? And the group 1s will always have a 1 plus charge. It's got that one outer electrons. Cations in the group 2 elements will always have a plus 2 charge. Magnesium, okay, which is electronically neutral, okay, it has 12 protons and 12 electrons. It'll lose 1 electron at a time until it loses those 2 valence electrons, all right? So it'll have a charge of 2 plus. So we usually write it like this. We combine it. We know now that it loses 1 electron at a time, but we can do like this. Magnesium 2 plus, it becomes the magnesium cation, all right, plus 2 electrons that have went away. Somebody got them. Anions are similar, right? These are nonmetals, and what nonmetals usually do is they will gain a valence electrons. And when it gains a valence electrons, it'll have a noble gas, 8 electrons in the outer shell configuration. So chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. It needs 1 more electron, 1 more silly, stinking electron, just 1 thin electron to be full. So chlorine, of course, it's got a whole lot of electronegativity. It'll take an electron, all right? Now, chloride anion, we call it that now. We'll learn more about how we name this one later. We'll have a 1s2, 2s2, 2p6, 3s2, 3p6 configuration, just like the argon noble gas atom. So, how many electrons does the chloride anion have? You count all those up, and you will count, that's 10, 12, 18 total electrons. Now, let's talk about the sizes, right? The chloride ion is going to be larger than the chlorine atom. What affects the size? Zeph and the number of electrons. Well, now you have 18 electrons, which is more than the Zeph. So what are those electrons going to do? They're going to stretch out. All right. The Zeph is not strong enough to hold those outer electrons together, so it's going to grow larger, okay, because it has less positive charge. Now, the anions of group 15 are almost always have a charge of 3 minus, nitrogen, phosphorus, and arsenic. Anions of group 16 elements always have a charge of 2 minus, usually. That's oxygen, sulfur, selenium, tellurium. So group 17, fluorine, chlorine, bromine, iodine, okay, they're almost always going to have a charge of 1 minus. In fact, they do have a charge of 1 minus. Now, let's think about group 14 elements. What charge do you think they're going to have? +4, -4, or it could go either way. I'd vote it would go either way, depending upon electronegativity and, again, depending on ionization energy. So, we got a couple of questions here. Let's do a check. Metals tend to what? Lose or gain, and nonmetals tend to lose or gain electrons. Take a moment. And metals tend to lose electrons, and nonmetals tend to gain electrons. Anions tend to be what? And cations tend to be what? Take a moment. Come back in a second. Pause it. And now, anions tend to be, of course, nonmetals, and cations tend to be metals. Metals lose electrons to form cations. True or false? Pause. And of course, the answer is true. Anions are formed from non-metals. True or false? Take a chance. And false, or true rather. Anions are formed from non-metals. Non-metals tend to lose electrons, forming ions. True or false? Take a moment, and of course the answer is false. False. I didn't go all the way. There we go. Well, it's false. Okay. Which is the ion formed from a calcium ion? Look at the group number, think about it, and come back. And of course, that's going to be Ca2+, cation. Phosphorus forms an ion with a charge of what? Look at the periodic table. What group is it in? Go back. A charge of 3 minus. 3 minus is going to gain 3 electrons to get that good, stable double gas configuration. Aluminum forms an ion with what type of charge? Take a moment, come back, and 3+. Aluminum cation is a 3+ charge. Of the following, which contains the greatest number of electrons? Take a moment. And of course, the answer is D, phosphorus, phosphide. Yeah, phosphide 3 minus anion. Oxygen forms an ion with a charge of what? Take a moment. And of course, the answer is A, 2 minus. Iodine forms an ion with a charge of what? Take a moment. And of course, that is 1 minus D, right? The iodide anion. This ion formed from nitrogen. Nitrogen, let's see, that's group, what, 15? So is it going to lose or gain electrons? Take a moment, and of course the answer is D, nitride, 3 minus anion. Predict the most stable ion of sulfur. Take a moment, and of course the answer is D, 2 minus. It's in group 16, right below oxygen. 23. What would be the expected charge on the gallium ion? Take a moment. Come back, and of course it is C plus 3. Plus 3. Okay, guys, so now we've covered ions. What did we learn? Well, we learned that you need what? Okay, you need your periodic table to figure out what type of ion it's going to be. All right, we know that the metals are going to lose electrons, okay, and become cations. Most of the nonmetals are going to gain an electron and become an anion, right? And they're trying to achieve a noble gas configuration, S2P6. Okay, guys, this is Coach Scott saying love you. Glad you're listening. And subscribe if you haven't. Okay, have a good evening, and we'll see you tomorrow.